Hello everyone and welcome to DataStax Monday Learning. Today with you, Cedric Lunden.
Hello Alex, welcome everybody.
Hi everyone, that's a big pleasure to be with you here today. And we are very happy to greet everyone who has joined our DataStax Monday Learning this week. Today we are going to speak about machine learning. If you are at our channel for some time already, you must know what's the DataStax Monday Learning is. We speak about the most important topics in the software engineering, from engineers to engineers, absolutely for free, whatever may be interesting for you, whatever helps you to develop the skills. And today that's going to be introduction to machine learning. And next week is going to be how to develop Kubernetes native applications. That's not only about Kubernetes, but in general. How do you develop applications? What can be successful in containerized environment, for example? So we invite you to join our upcoming workshops as well. And today, the main topic for us is the machine learning for complete beginners in this field. So don't worry if you don't have a degree in the whatever mathematics. You don't need that. That's for everyone to understand the basics and how it works in general. We cannot make you a master in 2 hours. We're always doing our best. But usually that's a little bit not enough, especially for such a topic. But after this workshop, you will definitely see and know how it works in theory and in practice as well. So that's a hands-on workshop. And you can first, and we suggest you first to watch how we are doing those things. And second, you are able to try everything on your own. And I will explain how it works in some moments. So, 2 words about myself. I'm a developer advocate at the DataStax. You maybe seen some of our workshops before, and we are very happy to greet you here. And that's Cedric. And
yeah, so hello everyone. I'm leading the developer advocate team. And as you can see, I'm quite a Java geek. I created FF4J, so feature flipping for Java open source framework 7 years ago. So it's all about enabling or disabling part of your application at runtime, no restart. And I also had the opportunity to contribute to Jeepster in the Cassandra part. Of course, I should be more in that, but I'm pretty happy to be with you. Alex is leading today, so I will be mostly watching your questions and comments on YouTube chat or Discord. Try my best to answer. You can do the exercise with us. We will provide you the materials, but please look at what Alex does and do the exercise maybe later, after the workshop, when you got the demo and everything, you will have the tools.
Exactly. Thank you, Cedric. So many people run and try to do everything at once together with us, and then miss what we are saying, and then ask the questions we've just explained it. We see it every workshop. But why it happens, people think what workshop is over when it's over, and we will be not able to ask questions anymore. Not with us. Staying with us, you always can do your workshops after time in any moment, and then ask your questions maybe at our Discord server. Actually, let me even show it for a second. We have a Discord server available to answer and ask all of your questions, and we are always there for you. We cannot guarantee we answer immediately, but be always there and someone is able to answer. There are many thousands of people actually using this Discord server, so we are always with you. Workshop is not over as long as you don't want to be for it to be over. Okay, we are here. No one is gone. So first theory, when you will put your own hands on that and do the machine learning on your own. Good. A few more things we are going to use during the workshop and after the workshop. So first of all, streams. We are doing streams at the YouTube, and Twitch. YouTube is the primary platform for us, so here we are answering at the YouTube channel on comments, and Twitch is kind of secondary. Plan B is something goes wrong with YouTube, we can fall back to Twitch. When to answer questions, you can ask your questions at the YouTube chat. It works, but as long as stream is over, comments are also gone. So we suggest you to use our Discord. Here we can discuss many other things over time, and you may have an opinion of other engineers, which is also great. Then, to do the exercises, we will use some runtime. That's an introductional level workshop, but we want you to be familiar with all the required tools, what people use in the real machine learning. So we are going to use some pretty heavy set of the tools today, and you are going to do it as well. And finally, materials. All the materials, all the things we do are available at the GitHub, and that's going to be, I guess, Cedric maybe copy it to the link or going to do it in a second. Thank you so much. Yeah, predictive thinking, of course.
Exactly. Yeah, predict.
With you, we don't need any kind of a machine learning.
Yeah, we are working those workshops for so long now.
Yeah,
man, it's only 6 months and 50 sessions.
Yep. So. Great. So, and now about the practical steps and hands-on part. You have two options. You can use your own machine, whatever laptop, PC you are using. As long as you have Docker installed, you can run our exercises and practical steps. If you cannot have Docker installed, or maybe your machine is not powerful enough, because, well, today we are going to do some computations and we need a database and other things, then it may be not a choice for you. When we have you covered, so you can use a cloud machine provided by DataStax. If you want to set up it locally, only thing you will need Docker and Docker Compose, and well, some CPU cores and memory, of course. And you can clone our repository and just Docker Compose pull, Docker Compose up, you will have everything. Another option, you can contact me by email or via LinkedIn, also works. And I will spawn a cloud instance for you. It will be the same, basically. So, those are the main things, but let's start with a little bit of the theory first. So, machine learning. Field of study what gives computers the ability to learn without being explicitly programming. Sounds exciting, but what does that mean and how it works? As very often happens, definitions from Wikipedia will not help us. If you know how it works and what does that mean, you don't need them, and if you don't, those definitions will not help you because they're, well, maybe too much academical. I prefer us to think of a little bit simpler definition. Machine learning is a science of drawing circles and colorizing them.
You should make that as, subtitles for the session.
Yeah, because that's what we are going to do, draw circle and colorize them. Yeah. So the trick is this definition also doesn't explain too much, but at least it's much shorter. That's already better. Instead of making a formal definition, I prefer to think of how it works and for which purpose would we use that. Briefly speaking, machine learning is a scientific way to process raw data using algorithms and make better decisions. That's it. So that's you're going to have the raw data you want to analyze. You need to use some algorithms. With those, you will process those data. And with that, with the highlights of this data you get out, you may make better decisions. No magic, just a lot of data and a couple of algorithmic functions. Only that.
Exactly.
What are the use cases for the machine learning? Well, very typical situation are the forecasts. If you want to have a price forecast, if you want to forecast a rating, if you want to forecast the weather, try to predict something in any kind of these things, that's a very good approach and place for machine learning. Aberration detection. A fraud operation in some banking, very typical use case. Intrusion alert also may be based on the aberration detection of a normal customer workflow. Disease detection, if we start to speak about medicine, which is a very much the case in the year 2020, of course, but also classification, face recognition. Who is that on that photo? Also, categorization. Again, speaking about photo, for example, but not necessarily. Is it a dog photo? Is it a cat photo? Or is it a traffic light? Same. Spam detection, which is a subpart of a categorization. Doing spam detection, we only want to know which category this email is. Is it a spam or not? Recommendation, suggestions, navigation, calculating of a shortest way, and many others. So there is a lot of use cases for the machine learning. Cedric, what would be your personal favorite of machine learning in real life? What helps you the most in normal life?
All good.
Cedric?
I'm back.
Oh, sorry. No, my question was, what's your favorite application of a machine learning in real life? What touches you the most out of all of those?
Um, touch me, maybe spam I get, it is really that what I use every day.
Yeah.
But, I see all the amazing use case that's coming, self-driving car,
Also,
GPT-3, the new killer in, unsupervised machine learning algorithms that doing stuff like crazy.
yep. My personal favorites would be also spam detection. I agree. So that's for the things that saves us a lot of time. But also, my personal favorite would be navigation. Because, well, in the last years we were traveled a lot, and without some good navigation systems, it would be much harder.
Oh, yes.
So, but how does it work? Machine learning works with very different kinds of data. Lines of user orders in Amazon data, lines of rows of any changes in any kind of banking operations data. Basically, so many of them that's nearly impossible to mention. Everything is a data we operate digitally. And then there are a lot of algorithms we may apply to the data to try to get some ideas, better ideas about this data. And there are a lot of them. Of course, we cannot make a dive to every one of them during this short workshop, but we will cover some of the most widely used ones. But before speaking of algorithms, we have to categorize them a little bit. So, there are two main approaches, two main kinds of machine learning we have to discuss: supervised and unsupervised. There are a little bit more, but that's a beginner level workshop, so we will not make a too deep dive. So those are two mains. And what's the principal difference? Difference is very simple. With supervised approach, data is labeled, or at least must be labeled. And then unsupervised one is data and not labeled, and we don't care about the labels. And now you ask, like, okay, what does that mean at all? And answer is simple. When data is labeled or must be labeled, we operate with some definitions like this email is spam and this email is not spam. This operation is fraud, this operation is not fraud. This subscription was cancelled, this subscription is active. So there is always a clear way, almost always a clear way to distinct entities, pieces of data one from another. And yeah?
No, I think we need to shrink.
Oh, you are right.
I see my head in front of test,
Yeah, hard to
Until
test.
now, hard to test, easy to test, If I
Boom.
put my face on top, it's even harder to test.
We are shrinked now. Good.
Right.
So.
Thank you, Jafrit.
So.
We don't always have the feedback loop. Okay.
So, data is labeled or must be labeled. It means what we are very often speak of a classification in the field of a supervised method. So we speak, for example, when your email service categorizes an email, incoming email, as a spam, it's only possible because billions of users, billions of times before, marked similar emails as spam. How it works, we will cover later during workshop one of the typical algorithms for spam detection. So classification is a very typical supervised method. Regression is a supervised method. Good side of the supervised methods, they are easy to test. Testing of the model is very important. Without testing, we cannot say if model is good or bad. And on the opposite side, we have unsupervised algorithms. We apply that for the cases when data is not labeled. And that's not our concern. It helps, it works differently, and it helps us, for example, to find unknown patterns in data. It's used for clustering, or less scientifically speaking, for grouping units into some groups, trying to find a way how could we group them together. For example, your application may have very different kinds of customers, and if you try to treat them all together, it means what your application will not be most comfortable for a lot of them. So you want to, for example, find different groups of people using your application in different days. That's grouping or clustering. Anomaly detection, the same way. Associations between units you're working with. Very useful in exploratory analysis when you actually don't not yet understand the full size and meaning of your data, and you want to walk through that and see what you have, and many others applications. And problem of unsupervised learning is it's much harder to test, as we don't have the labels, we don't have the text. As a result, it's very hard to judge if the model was correct or not so correct. Maybe we will play a little bit with those kinds of machine learning today. And finally, let's take a bit closer look on how it works. Start from the very basic example.
This part is pretty cool.
Yeah, I like this one. I want to
the demo is great.
reset that. I want it to be empty. Yes, perfect. So, k-means is unsupervised mechanism. And it works in the very simple way. It allows us to, it helps us with clustering. So it's a clustering algorithm. It helps us to cluster things. And it helps us to group the things. Imagine I have two dots, only two dots for the beginning on the screen, and I want to have, and I want to publish, and I want to find the center for every of them having two clusters. And I prepare those two data dots, and I play just one iteration, and I have this k-means mechanism algorithm highlighted those for me. It works in a very simple way. Given you have multiple clusters, k-means tries to calculate the center of those clusters for you. So now I see what I have two clusters. And starting with this simple case, how it works, imagine I have a city. And in this city, there are some groups of people who love pizza. And I'm going to sell pizza, and I have limited budget, so I want to put my pizza bakeries, or how do you call it in English? Pizza stores? Not stores. Whatever.
I know. Pizza Hut.
Pizza houses, yeah. Pizza huts. it will work.
Pizza.
Okay.
No, it's a brand.
I
We
want.
cannot.
Yep.
Yeah, no, it's Pizza House. I
Pizza
don't know.
House
Pizza.
doesn't matter. Yes, I want to put them as close to the centers of my potential buyers as possible to help visitors to visit me, and also shorten delivery time for those who order pizza to home. And
yeah, if you can share the link, I think that people want to play with you.
oh yeah, because that's a great link, and I will share it in a second. Thank you so much.
It's a little bit too small for me.
Oh,
all right.
Okay.
Thank you.
It's done. Good. No, I cannot make it bigger. Okay. So how and I want to find perfect center for my pizza houses, and I have those addresses, geographical coordinates. How this algorithm starts to work? At first, it puts these theoretical centers, points, centers of clusters, just randomly. You see, I'm pushing reset button, and every time they appear on a completely new place, and there is no dependency with the location of all the possible points. It doesn't matter, you just put them to a random place. You may say, like, that sounds pretty stupid to me, I don't need machine learning to throw some things randomly on a map. And well, you don't, but that's only beginning. And let's see how it will very quickly adapt to the situation, iteration over iteration. So, how it works? It calculates the length and the vectors of all of the lines it has on the screen per cluster, and then sees if we are to move cluster center, because now this cluster is not perfectly positioned, obviously, and this one is very not perfectly positioned, because this one even has zero connection. All the dots are closest are connected to the red circle. Why? Because it's the closest to them, and therefore blue one has no connection at all. And now I press play one time, and red one moves based on the vector, so it tries to be the center. But again, it doesn't work so much because we are in the middle, and on the next iteration it tries to move to the next possible center. And now we see something already very close. Our clusters are mostly done, except of one thing. There is one more dot which will be recolored with next iteration. Now we are done. Clustering is finished. We have had two groups, we have had two clusters, and now they're perfectly grouped. But well then, what does that mean k-means? It means what you are going to specify the amount of clusters. And here I can specify amount of clusters I may have. And if I specify, let's say I will keep 2 for a second, but I will add one more cluster, then situation gets better, gets not so good. I will proceed with my iterations, and now this red center is located in the bad position. So because I've asked this k-means algorithm to have only 2 clusters. Now blue points are fine, but red point center is well, pretty bad, because to all of this group it will be way too long way. But actually for the red group on the south it's also bad, because it's still on the side of the circle. But if I increase amount of clusters, first I see, so it was randomly allocated here, again it's perfectly fine. And I start to do iterations again. Okay, and that's a deadlock. We are very lucky to see this situation today. It happens sometimes with k-means algorithm. It gets into deadlock. That's a coincidence, but I'm happy to have this coincidence. All lines, all dots are already kind of allocated, and k-means doesn't want to rearrange any of them, because kind of we are done. That's it may happen with k-means, especially when we are adding things like that. So I will reset that and start again from scratch. And we will see, okay, the same situation happens. So that's interesting point. Initial position in the k-means algorithm matters. Although it's random, it still matters. So after a few randoms, now see this position, I restarted algorithm. We will have point, 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 boom. In 3 clicks, in 3 iterations, we are done, and now they're perfectly clustered. And that's pretty interesting thing for us to consider, what the distribution of clusters depends on the initial position of the centers, and it may vary. Okay, and if we go for this one, it will be rearranged pretty soon, also in some jumps. Now notice one more thing. Amount of clusters is for you to define. So in this case, we have 4 visualized, not defined yet by machine learning, but we see it visually. We have 4 clusters, but only 3 clusters for k-means algorithm. What does that mean? Obviously, it will try to group them in a different way, given you use as much clusters as you specified. And in this case, for example, it will lead to clusters like that. And whatever you add anyway will be tried to allocate as best as possible. There are some more. This thing is a really great way to play with the k-means. You can use some predefined set of values, especially with more complex one like 5 or 6. That's interesting to notice what the default k-means will never work good on these complex data sets like those, because however iterations you want to do, it will go by default with the simplest possible approach.
You're an artist.
Yeah, but yeah.
So for people asking, so how do you evaluate what should be the K? So my first answer is really, it all depends on your resources first. I mean, if you want to create pizza stores, you don't have a limited amount of money. So first you know how far you can go to build those houses. So you see if 2.5 and 3 is a huge improvement. So how do you measure this improvement? To me, it's like the average distance between the center and the points does not change a lot. That means you have reached kind of a optimal K. And there is a scientific method to evaluate this K, and it's called the elbow method, and I just share the link on the chat for everyone.
Yeah, so it depends on which side do you pick. Sometimes business defines your requirements. I don't care how many pizza lovers you have in the city, we have money for 2 pizza houses, take it or leave it. So in this case, you go with 2 clusters and like you don't have any much choice. Yeah, things like that. In some cases, well, so that's in general long story and a good question. Thank you, Cedric. So we have to move on.
Go.
Yep, good. Okay, so learning workflow and how in general it works. We should not forget what first thing comes first. And the most important for us is the question or hypothesis you want to answer. If you don't know what question do you ask, then doesn't matter what you do afterwards, you will not have a good answer. No way. So first we start with a question and hypothesis. Then we have to pick proper algorithm. If it's supervised learning, for example, you have to pick one of the supervised learning algorithms. Which one to choose? Well, data scientists got their jobs and salaries exactly because they can easier answer to these questions. It's not a
Huge
simple.
salaries.
Yeah, and sometimes you need to have ensemble methods when you apply different algorithms in different way. But again, that's an introduction level workshop. So we will give you a couple of ideas today, and you will see. When we have to prepare the data, split the data into groups. use this first parts of the data to train model and use others to tune and estimate that. I will show it again in a moment. And if we are satisfied with the final model, we can use it already in production. So, speaking of step by step, how does that look like? At first, we go with preparation. We remove redundant things. We vectorize the things those has to be vectorized. We put labels on. We will show it on a practice in some minutes. When we split data into 3 sets. First set, usually the biggest one, around 80%, 70%, will be used to train the model. Validating set is used to tune the model, and testing set is used to estimate the results if we are satisfied with the model behavior or not. Good. Then, if we are fine with the model, we can export this model and already use that for the real workloads. For example, if we work on the spam emails, in the beginning, at the first step, we will label emails manually, literally manually, if this is spam or not. But this job is done already or being done regularly by everyone who is using spam and pushes the button spam, don't show, throw away, delete, sender. When we train model based on those labels done, we test model if we are satisfied with the accuracy and other things based on the testing set. And finally, we use this model, put new emails there, those weren't labeled by human, and use it to define and predict, for example, if this email is spam or not. And I know you can't wait to put your hands on and finally push some buttons, but before that we have to do one more things. Metrics, because you cannot control what you can't measure. We are going to work with supervised algorithms mostly today, so we will speak about the things those are easier to test. And we work today with an example I don't like so much, but it really matches the topic of the year 2020. We speak with a tumor example. For this example, we will work with different metrics. We have the situation: 100 people, all of them are sick with all of them have tumor, but 9 have malignant tumor, which is very bad, and 91 have benign tumor, which is also bad but not so deadly. You know, maybe machine learning is used very widely in the medicine. So then we created a model we are going to assess, and this model, working with this 100 people's data, gave following results: true, negatives, 90. It means what model defined people having benign tumor, so just bad tumor, 90 people, and that's a true negative. So they don't have malignant tumor, and reality benign, and machine learning predicted it correctly. It's called a true negative. And we gave 90 out of 91, which seems to be a good score. True positive was 1, so we have 9 people having malignant tumor, and our model guessed one of them. This is a true positive. It was real, and we guessed it correctly. When we have two possible false results, false positives and false negatives. False positive means what person didn't have this malignant tumor, but our model identified him or her as having this malignant tumor. Now, 1 person, and 8 more false negatives. So people had this very bad tumor, but we identified them as being having just bad tumor, 8 of them. That's the example. Now we will try to assess, is this model good or bad? And the first metric we use about speaking about the model is the accuracy. Accuracy is a metric Basically, just a fraction of predictions model identified correctly. Calculate accuracy is very simple. You get the correct prediction, so true positive and true negative, and divide them by total predictions. In this example, we have accuracy 91 divided by 100, so 0.91 out of 1 possible. It's pretty high. So 91 is true positive plus true negative divided by total predictions. 1 plus 90 divided by 100. Accuracy seems to be pretty high. Now the question is, model looks good or not? Try to think a little bit about that. I will give you 5 seconds. Okay, let's take a look. We send back home 8 people without proper treatments.
Yeah.
We could have better result by literally throwing a coin. Literally. What's the case? The accuracy is pretty high indeed. Like very close, 91 out of possible 1. That's pretty good. What's wrong then? It means what accuracy is not the only one, and maybe sometimes not the most important metric. There are some more metrics we can discuss, and main of them are precision and recall. Precision, also known as positive predictive value. Precision counts true positives out of all true and false positives. So that's the ability of a model to make positive precisions, to make positive decisions. Precision is amount of true positive divided by all positives. And for our example, we are covering, for the tumor example, our precision is 1 divided by 1 plus 1, so it's 0.5. And that doesn't look as good as 0.91 as the accuracy was. So precision of a model is already, let's say, very medium. But what happens with the recall then? Recall is another metric, and also very important metric. Since it's also known as sensitivity. Sensitivity counts correctly identified positives out of all real positives. So, sensitivity or recall, you name it, you can use both names. Recall is amount of true positives divided by all real positives. So, for the tumor example, recall is 1 divided by 1 plus 8, so 0.11. And that's a very, 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 very bad result. So it looks like our model at the same time has pretty high accuracy, middle precision, and disastrous recall. And for this kind of a medical experiments, you see, what's more important, accuracy, precision, recall, it's maybe different. It depends on your use case. It depends on what exactly you calculate. But we can see what for medical decisions what can save someone or kill them, then accuracy is not the only thing you have to consider. But you may definitely want to notice the recall. So true positive to all real positives you have identified. And last thing before we go live with the practical steps is simple explanation of underfitted, good fitted, and overfitted models. Take a look. Dots on this example are the pieces of data we have. So those are 3 exactly the same pieces of data, but we use different models. And the dotted line is the results of a prediction of this model. And what's the difference of them is data is the same. Underfitted model will be not accurate or maybe too simple. That's like when we use it k-means clustering and gave enough, didn't allow that to use enough clusters. It will try to put it all together, but result will not be perfect. And that's mostly the same here. We see what general trend of the data here goes like that over time. But our model only tries to be like that. It means our model is underfitted. It's not accurate, it's too simple. Vice versa, on the opposite side, on the right side, we see overfitted model. And this is an overtrained model which tries to catch every dot on its way. And instead of a nice, sweet general line, it's trying to jump high and down, and then as a result, it tries to catch every dot. But overtrained model is also bad because it doesn't allow us to catch the real trend. Model should not try to catch to be perfect. We never want to have 100% accuracy, recall, and precision. First of all, it's not possible, and second of all, mostly probably it's not going to work in the real life.
Yeah.
Overtrained one is bad as well. It's perfect on the trained data, but as soon as you start to test it, you find what it's not able to catch any general trend you want to see. And finally, good fit or robust model doesn't try to catch every point into the main line, but follows the general idea and allow you to give the predictions not too different from the real value. Good. And you know what? Talk is cheap. Show me the code.
Show me the code. Oh, show me the demo.
Yeah. So, but before we start, we have to cover the tools we are going to use. And luckily enough, we are going to use the tools on the left of the screen, not on the right. I hope you too. But you know what? Year 2020 is not over yet, so maybe we will need those on the right as well. So, we are going to use multiple tools, and I will briefly explain what's going on here. So first of all, we don't need so much tools to just run a single simple machine learning algorithm on our own. You can do it with Python and a couple of libs on your laptop with no problems. But we want to show you how it goes in the real world, so we will mention a couple of more topics. First of all, first tool we are going to discuss is Apache Spark. And formal definition, as always, perfect. Apache Spark is an open source distributed general purpose cluster computing framework. Perfect. But in short, take a look. Today we are going to work with sample data. And there are data sets like about 6,000 rows of data. Then that's not much. But in real life, you may want to work with billions rows of data. And obviously, your laptop is going to commit suicide after a couple of hours of work like that. To avoid that, we have to distribute the load. So Spark is a computational framework which helps you to distribute workload over multiple servers. Simple as that. That's like to distribute workload of your laptop to multiple servers. Simple as that. Then, Apache Cassandra. Maybe you was at one of our previous workshops. I will not stay for too long at this topic, but in general, Apache Cassandra is a perfect database for the big data use cases. It's a free, open source, distributed, decentralized database, which helps you to handle any amounts of data you want to handle. And if you are interested to see which database is used by companies like Apple, Netflix, Instagram, Huawei, and many others, and how do they handle dozens petabytes, dispatching them within very milliseconds, then you may want to attend our Intro to Cassandra workshop this Wednesday and this Thursday.
Yep, please.
Yeah, but in short, Cassandra is a database which is ready to handle any amounts of data. It's a very big data ready, and it's very quick. So even on the highest load, it will dispatch your queries very quickly. It's a good fit, and they are very well integrated with Apache Spark and Apache Cassandra. You will see it in a moment. Then, Jupyter and DataStax Studio. in the simple explanation, Jupyter we will use today as a web interface to Apache Spark, and DataStax Studio we will use as a web interface to Apache Cassandra. It's a little bit more complex than that, but doesn't matter right now. DS Studio and Jupyter we will use today just as web interfaces. And then finally Python, and do you need me to explain you what Python is? It's a programming language. That should be enough for today.
It's a serpent.
Yeah, yeah, it's not as cool as glorious Java. Yes, Cedric?
It cannot be.
Of course, nothing can be cooler than Java.
No, but you know what? I think it's now more popular than Java.
Yeah, maybe. I mean, that's world goes to hell, you know.
Yeah, we need to move on.
Good. So there are two main languages in the machine learning, Python and R. There is a very long and holy war question, which is better. Well, personally, I would stick to Python because I was using Python a lot, and that's for me obvious answer. For you, answer may be very different. Today we use Python. If you have experience with Python, it's great. If you don't worry. The examples are very simple, so if you can read English, you will understand what's going on. And then some more tools important for us. Pandas. Pandas is a Python package or library providing different data structures we need to work using machine learning. PySpark is the library for Python to be able to connect to Spark to distribute workloads over Spark nodes. NumPy is the kind of a most well-known package for any kind of scientific computations with Python. Whatever relates to mathematics, mostly probably part of this package. And finally, scikit-learn is not exactly a library, but more of a set of libraries, set of packages we use for machine learning, but also for visualization. You know what? Humans are not computers. We prefer to see with our eyes. So scikit with its parts very widely use it to visualize the data, which you will see after a couple of examples.
Yes, and as scikit-learn was there in the beginning, they provide a decision tree, kind of beginning of decision tree. Which algorithm should you use based on the question you asked? So should be a regression, should be classification, clustering, and depending on how much data you have, this is first decision tree. It's not silver bullet, but that's worth mentioning. I shared the link on the chat.
Yep.
I can read you.
Thank you. So, environment is going to be very simple. In the center, we have a main thing for us, which is Apache Cassandra and Spark. This workshop is completely open source, and you can do that exactly with absolutely open source tools. In this case, for just the convenience of the usage and packaging, we are using Spark and Cassandra united together as a parts of a DataStax enterprise package. But don't focus on this part. You can have the same with Apache Spark and Apache Cassandra. They're just for the convenience for us to deliver the workshop. So Cassandra use it for data storage and Spark use it for analytics. And DataStax Studio is the web interface we will use to work with the data in Cassandra. And Jupyter Notebook is the web interface we will use to work with analytics in Spark. And in your environment, I will skip this step for a moment, sorry. So we can finally proceed to the practical steps. And first hero of our day is the naive Bayes algorithm. One of the oldest and most well-known algorithms, has pretty simple approach and stays very, very efficient meanwhile. It's a classification algorithm, so supervised. As usual, my favorite wiki definitions aren't so helpful to us. Naive Bayes classifiers are a family of simple probabilistic classifiers based on applying Bayes' theorem with strong naive independence assumptions. I don't like this one. Let's find something easier. This cartoon comic is the simplest yet great explanation of naive Bayes algorithm. Statistically speaking, on the big numbers, if you pick up a seashell and you don't hold it to your ear, you can probably hear the ocean. And that sounds a little bit weird at first, but let's make a little bit deeper thing. So, people speak, what's the probability of x when y? When we want to write it down on the scientific way, we use formulas like that. P, parentheses. On the left side, we have what do we want to check? What's the probability of the fact of this statement given right part of the statement. So part on the right side, it's a fact. Probability is 100%. It's already happened. I pick it up as seashell. And on the left, what's the probability I'm near the ocean? Altogether, you read that. What's the probability I'm near the ocean given I pick it up as seashell? So you see now that's a very scientific way to write down simple things. So now if you want to look like a data scientist, you know how to write these probability things. Very simple. And now it goes to the example like that. We can calculate this probability based on the very simple way. That's kind of reverse dependency. If I know what if I can to decide, I pick it up a seashell given I'm near the ocean, this probability multiplied by the fact I'm near the ocean and I pick it up a seashell, then I can hear the ocean. So I'm close to that. That's easier to show on the spam example, actually. Let me move on. Because, well, that's too many ocean. And we want to work with more simple things. So, as you remember from the workflow, we start to work with preparation and labeling of the data. In this example, we have some emails. Specifically speaking, we have 1, 2, 3, 4, 5, 6, 7, 8 emails, and we have to label them. So don't forget, if you are getting no spam today, it means what many people before you were labeling spam as spam. Thank to them. So after manual processing of those emails, we have already those two data sets. We know with 3 emails were spam, money transfer received, get cash easy, win money now, a spam, and we have 5 emails, those are not spam. Greetings from Dad, could you lend me money? It was easy, I miss you, check your trip itinerary. Very well. So, what do we do then? How this algorithm works and how do we apply that? We have model based on the naive Bayes algorithm. It's trained on these 2 data sets. Those 3 emails are spam. Those 5 emails are not spam. How does that work internally? I receive new email. Easy money. Is it spam or not? As said before, how human says it? What is the chance it's spam if it has easy money subject? A scientist writes it down. What's the probability it's spam given it has easy in money in the subject? We want to calculate. Now, there are 3 probabilities we have to consider following naive Bayes algorithm in this case. First probability based on word easy, because it's the first word in the subject. We work only with subjects today, okay, to make it simpler. Second probability we want to calculate is based on the word money. And the third probability we want to calculate is the general probability of an email being a spam. And in this case, we have 8 emails, 3 of them are spam. So the probability is email being spam without any investigations is 3 out of 8. And email is not being spam is 5 out of 8. Based on those simple data sets we are having right here. And now we want to take a look at the following things. Word money. 2 of the spam emails had this word in them. So it's 2 out of 3. Therefore, probability of email will have word money in subject given its spam is 2 divided by 3, and this is a very important thing. That's kind of a reverse dependency, you see? Now we are judging on this word given labeled emails before, and we know what in 2 out of 3 spam emails this word existed in the subject, and therefore probability is 2 out of 3. And then only in 1 out of 5 emails not spam this word was a part of a subject. Only 1, so probability is 1 out of 5. And when we do the same work for the word easy, it was in 1 out of 3 spam and 1 out of 5 not spam. Therefore, probabilities will be 1 divided by 3 and 1 divided by 5. And now comes the most important thing about this algorithm. Very simple one. The email can be or spam or not spam. In the real world, it's a little bit more complicated.
Yeah.
Sorry.
It can start. No, it can start marketing and then become technical on the other way around.
Yeah, absolutely. And you know what? That's fine, but for the simplicity of our example, we will cover simple probability. Email can be or spam or not spam. And here is the trick. The overall probability of those spam or not spam equals 1, because email can be or spam or not spam. And based on that, we can calculate the final proportion, the final result of these email to be spam or not. On the first step, we simply multiply probabilities of all our things. Probability of all the numbers we covered. First one, we know what probability of any email to be spam, 3 out of 8. Why? Because we have this data set. 3 email were spam, 5 weren't. So 3 out of 8 are spam. That's this part. Very important part for us, what email has the word money given its spam, 2 out of 3. So this reversed thing. And finally, probability of word containing easy given its spam is 1 out of 3. And we calculate and we receive 1 divided by 12. And the same goes for the probability of a not spam. So we know what 5 out of 8 emails are not spam. We know what word money was only in 1 out of 5. And word easy was only in 1 out of 5 not spam emails. And it will be overall 1 divided by 40. And now finally, we finish this little game bringing 1 divided by 12 and y divided by 40 into the same values. And we have now 10 out of 13 and 3 out of 13. And now based on that, we can say what probability of email is being spam based it has easy and money on the subject equals to almost 77%. And notice how cool it works. Even out of 8 emails, we calculated the probability of a new email to be spam pretty high. And well, it is spam. So, obviously, usually naive Bayes algorithm works not with 8 emails, but more about 88 billions emails. And when this efficiency of this algorithm goes very high. So, it's based on Bayes theorem, but why naive? Answer is very simple. In the real life, we have the dependencies between different facts. If I write the word happy, then probability of the next word to be birthday is significantly higher than to be another word or something bad. If I say long, long ago, then someone may proceed with a higher probability in a galaxy far, far away. They are not random facts, but they relate to each other. And the limitation of naive Bayes algorithm, what it considers every fact as a standalone fact without relating to others. And you may say it's kind of looks a big problem, but it isn't. Because again, on the big numbers, it already is getting very fine to work like that. And it also works when you can ignore those dependencies, not trying to calculate the relations between words and calculate dependencies of them, then that's very easy to make parallel and to distribute your workload over multiple servers, making it very efficient. As it said on the example on the right, for a human understands what outside can be or warm or cold, but not both warm and cold at the same time. For Bayes, it's not so obvious for naive Bayes implementation of algorithm, but it's still perfectly fine as long as you have big pieces of data. So in this case, we calculated those reversed dependencies and got a very nice result from the very simple approach and on a very small data set. Let's try to use this algorithm on real life. So, as said, we are going to work with two web interfaces. Actually, mostly with one today, I would say. Because main hero for us is the Jupyter and Spark for this workshop. And we have 5 notebooks here. We will cover 2 today, and we will keep 3 for you to self-investigate. And you can play obviously with those 2 we are going to use today as well. Don't forget, workshop is not over as long as you don't want it to be over. And we proceed with a naive Bayes algorithm. As our special guest today is Cedric, this workshop is dedicated to wine, and we are going.
Of course,
yep, and we are going to try to predict wine quality based on the chemicals it contains.
Yeah.
And well, I'm not the best expert in that, but we know whom to ask if anything goes wrong.
Yeah, it cannot be correct, right? The only way to test a wine is really to taste it with your mouth.
Yeah, so if cold machine can try to predict and define wine quality, it's bullshit.
I predict that the machine cannot predict the quality.
We will see. You know what? Machine learning is an iterative algorithm, iterative approach, so maybe at first we will fail, but when I will try to find something better...
Let's see. Suspense super high now.
Good. So, how do we use those? If you didn't use Jupyter before, it's a very simple thing. You open a notebook. You have different cells here. And actually, I have... Okay, that should be good. Yes, I want to restart and clear it. Oh yeah, very good. Now it's what I want to have. So, our question, don't forget, it starts with question, is can naive Bayes be used to classify a wine's rating score by its attributes? I will execute those statements step by step and we will see how it goes. First 2 statements we have to execute, first 2 cells we have to run. It's the cell and this is the cell. Just to import required dependencies and import required libraries. So important thing for us here, we are going to work with Cassandra. We will import PySpark to work with Spark from Python, pandas as discussed before. And now some interesting things. PySpark machine learning, we will use naive Bayes from classification package. We will use multi-class classification evaluator to test our model and see if it's accurate or not. And we will use some more features we need to prepare the data. By the way, you see this interesting thing, PySpark.sql import Spark session. That's a very interesting fun fact if you know how Cassandra works. Using Spark, you can run SQL queries over Cassandra. So it's no SQL database, but with Spark, you can do SQL queries over it. Then, third cell I want to run, very simple. It just defines the decorator, the function we will use to show some data. If you know how Python works, that should be enough for you. We just define a function, name it show data frame, just to see their nice visualize it. Then, first we are going to connect to Cassandra, and we will create a data space we are going to work with. That will be create key space, if not exist, accelerate, replication simple, replication factor 1. For the demo, we don't need anything else. Very well, and I will set these key space as the default one. Now, we will prepare the table we are going to work with. And this table will be very simple. Every of the vines we are working with has some chemical values, alcohol, and quality. In this case, those all are chemical values, chlorides, citric acid, and so on and so forth. And quality is different. Quality is kind of a label given by some experts who tried this wine and said it's great, or maybe it's not so great, or maybe it wasn't a wine at all. And they are going to work with those. And also, of course, every wine will have an ID, because we have to operate with the data. All of them are going to be float, except of wine ID, which is going to be integer. Good. Now, next action, we have to load some data we are going to work with. So it will be two data sets loaded together, but we load it from two different files, white and red. So it's going to be very simple, very primitive approach. Usually it looks a little bit more complicated, but we want it to be obvious. We open file data wine equality red vines, and load and insert those statements into the database. Of course, when you work with bigger data sets, you may be probably going to use dsBulk on other tools or other tools like that. And exactly the same operation, but for wine quality white. So two data sets. And I put them into the same table. For our investigation, we will use both red and wine together. While it's loading, Cedric, why do you need more than two kinds of wine? You have red, you have white. Why do you need more?
Oh, because it's not vodka. It's just burning your mouth with no taste, you know? There are some flavors and subtleties, fine stuff, fine grain quality.
Who cares about flavors? Okay.
Red and wine.
So we loaded the data meanwhile, and now we are going to work with Spark. So, and how about Spark? What does it do? At first, we are going to get Spark session. That will be an object called Spark, which we will use to work with a Spark cluster. And first thing I do, I create a new data frame. Data frame is the main thing in Spark. So that's the data frame, data set we are going to work with. So I'm asking Spark to read in format or Apache Spark SQL Cassandra. So notice how easy it is to read data from Cassandra with Spark, thanks to data stacks, by the way. With options, we are going to use table vines, and we are going to use key space accelerate load. I execute this statement. When you work on the bigger data frames, it may take much longer time, but now it's going to be pretty quick. We have 6,497 vines in this data set. And we see how it looks finally in the end. Vine ID, alcohol, chlorides, citric acid, and so on and so forth. Very good. Now, we don't want our model to work with redundant data, and we don't our model to work with bad quality wines. So what I'm going to do is I'm going to sort out all the wines of a quality lower than 6. So here I'm running a Spark command with wine data frame to filter based on quality, and quality must be higher than 5. I run this one. It's going to be pretty quick because we don't have too much data. And now we have this table smaller and all the wines with a quality of 6 and higher. Then we have to convert some data to be in a proper way for the model to work with. First thing we do vector assembler. And this vector assembler, for this vector assembler, we first have to define input columns based on the chemical consistency and chemical properties. And output column, which I will need for this one, is called features. And I have here this training data based on the assembler I've prepared, so it will be vectorized in the end, and I use this assembler to transform wine 6 data frame. And finally, one thing I have to do here, label indexer, string indexer will help me to convert input column, call it quality, so it will be label, and I only need that to, so that's a supervised mechanism, and I need labels. Data has to be labeled. For me, the quality rating is the label which helps me to group the wines out. Good. And as a result, we have training data 1 based on what label indexer did with the data from training data. So now all the data is prepared, and we can start. We vectorized entities and prepared them, and we made a proper label based on the quality. So now we can start. Not yet, I forgot to push the run button, but it will not take for too long. Good. And now happens the most important thing. Stop. Not yet. We have to split the data. In this case, for the simplification, I will not use cross-validation, but simple testing. We will go with, first we random split. First part will be 0.8, second part will be 0.2. So easier speaking, 80% go to first split, and 20 seconds go to second split. And I execute this run. Good. And now I have in my train data frame 3000 and 300, blah, blah, blah. And in test data frame, 747 rows. Now finally we can proceed to the naive Bayes algorithm. So we prepared everything, and now we can do. At first we define a naive Bayes algorithm with the default settings mostly. And first main thing we do is model and be fit train. So I put the train data with the fit model, with the fit method of this model, and it may take some time, especially on the larger sets, like really big time sometimes. And when I'm trying to use test to do predictions. So don't forget, what's the main difference between train data and test data? When we work with train data, when a model has access to all of the qualities we gave, and also final result, label or quality, doesn't matter. And when we are doing test, it will be different. So for the testing purposes, model has no access to the quality of the wine in this case, because we are checking the model, is it correct or not. So we can take a look at those predictions here given. And finally, we are reaching the end. We see what we predicted, some values for the test sets. And now we can use multi-class classification evaluator to evaluate the accuracy of our predictions. So we ask classification evaluator to calculate the accuracy for the given set. And
Moment of truth.
yeah, that's very
Can we
interesting.
trust machine to test wines?
Evaluator, evaluate based on the predictions given, so we will see the test result. And it evaluates, and it has set accuracy 0.6. So
Yeah.
maybe we should have called it Cedric instead.
Yeah, I could do better, I guess.
Yeah, well, you know what? 0.6, even I can do better. Maybe. Not sure. But you know what? It's an iterative process. So let me make a second attempt. Maybe this time it will be better. Maybe we will not need
Random
Cedric
forest.
afterwards. Now, one very important point. When you close Jupyter notebooks, they are not stopped by the default. So if you see it's still green here. So if you run them one by one, we are going to consume more and more memory. So what you want to do is to switch to running as long as you don't need them and shut them down. Otherwise, it may be not so good for you from the memory consumption point of view. If you have some weird problems, try to shut down the kernels here. Okay then, so let me switch then to the next algorithm we are using today. The third one and the last one. First was k-means, second was naive Bayes, and third one is random forest. And you maybe have noticed it already, what it's called supervised classification ensemble method. Not an algorithm. What's the trick? So, it all comes from the decision tree, which is an algorithm. Decision tree algorithm idea is very simple, based on the features, and that's a supervised algorithm, don't forget, so we can easily prepare test data and train data and so on. It tries to operate with the probabilities properly to build decision trees out of nothing using the features, and given it's no labels, it's a supervised algorithm again, so it knows labels, and that's how a simple Titanic survival decision tree would look like if we would try to build a decision tree to work with the chances of the people to survive in the Titanic disaster.
Jeez,
Yeah.
after cancer now you don't talk about Titanic. Man, let's talk about how to win the World Cup of soccer or something like that.
That sounds also good, but you know what? When we will get back to the wine to celebrate those.
Yeah,
who
wine is
survived.
okay.
Yeah,
Yeah, let's go back to wine.
Good. So, random decision tree is the way for the algorithm to create questions and try to get closer to the classification based on the answers. And in this case, we can get all the Titanic survival decision tree based on 3 answers. We can try to create multiple decision trees and then find the one what works better, or try to adapt it with different questions. In this case, every how to say person in this story we work with has 3 possible properties: property gender, property age, property siblings count. So how many brothers and sisters this person have had on board. And given these just 3 questions, we can very easy identify the percentage, the chance for the person to survive, given on the statistical data we have over this dreadful story. So very simple as that is gender male, yes, no. We go to the age and we go to a sibling count at the very end, and altogether those chances making the numbers what we need. And by it is especially on the like not so many features set data, decision tree as it is works, but it has one big problem. It tends to be overfitted. It tries to guess every point on the line, and as a result, it's not general enough and it doesn't work. To fix this problem of a decision tree, people started to use random forest ensemble method. Idea is very simple. Don't trust a single tree. Generate multiple of them and then try to measure based on the validating data which one is more correct and which one is wrong more often. Try to discard the results of those who is wrong all the time and give the higher weight to the decision tree which is more correct. This way we are trying to identify the questions, features and values what are the most important for the result we want to see in the end. So this random forest is a method to have multiple decision trees to answer different questions and to find proper results without this tendency to be overfitted. So trying to make a good fit, robust enough model. And let me take another approach to maybe try to replace Cedric in the list of wine experts with new shiny model of the machine learning. Sounds pretty skeptical. Sounds pretty skeptical.
Yeah, but you know, I was thinking my accuracy decreases over time.
Yeah, machine learning is never tired. So let me take another approach. We will see. I'm launching random forest notebook, and that's the same data set, but a little bit different algorithm. You will see. So at first, I'm importing my dependencies, and I'm defining data frame. Oh, okay, just a second. Yeah, it will be better. I want to start from a complete scratch with no leftovers. So I will do it again. We define again this decorator function. We will need to show nice things. We connect to Cassandra cluster and we create the key space, or actually we don't need to create it because it already exists. Very good. We have to set the key space to be accelerate. And this table already exists. You know what? For the clean result, let me wipe out this table actually. I want it to be perfectly clear because we have some leftovers. So I didn't get if it's executed. Okay. Good. Set key space. And table. Okay. So we discussed this data set already, so I will not stop on the chemical qualities, chemical properties. And let me check. Okay, so data is here. And we can check again what data frame works and shows us everything what we want to see. Now we also again separate lines with bad quality to a higher. We are going to work as in the last example with a higher number. And we do a similar preparation. So we will use a vector assembler to make those input columns the vectors, featured vectors for the model we are going to work with. We will need string indexer, again to convert quality into the label. And that should be enough for us to prepare it completely. Looks good. And now we do splitting again into two into train set and test set. And now comes interesting one. So we are going to use random forest classifier. As I forgot to mention, it was defined in the beginning. In the import part, we will use random forest classifier, not a naive bias, because, well, that's another notebook and we want to test another thing.
But that's still classification.
Yeah, that's still classification perfectly. Label column will be label for us, so our quality. Features columns, so based on what are the features we are going to judge. That's the feature columns we prepared before here with vector assembler. And finally, number of trees we are going to have. By default, we are going to have 10 numbers. So 10 trees united into one single forest. And we are doing here training. We are preparing predictions based on the test data and showing those tests. Good. We can show the predictions, showing some of the values done. We work with quality, expected quality, label, prediction, and probability. And finally, we can use a multi-class classification evaluator, already familiar to us. Label column will be label, prediction column will be prediction, and metric name we want to get is the accuracy. We calculate this accuracy and print it. So let's run it. And now the number is 0.68. So closer to 0.7. We aren't good yet, but we are definitely making progress on our way to try to replace Cedric with machine learning.
Yeah.
And what you can do and what I suggest you to do, there are links to the things we are doing and what you can read. Important for us would be we can try, for example, to change number of trees and use 20 instead of 10. I can just restart from this position. Don't forget, okay, show df is not important for me, but I can take a look at this one and see. Okay, so increasing the number of trees in my random forest, I got a little bit plus to my test set accuracy. And that's pretty interesting. So that's a pretty long story. It wasn't a simple workshop today because we are opening a great, incredible new field.
Oh, yeah.
Huge field. There are so many people working of very many different job titles, let's say data engineers, data scientists, taking care of different things. But that's a great new world that's very interesting to try to play with. We have no chance to make an expert out of you within 2 hours or 90 minutes, no. I would better say. But you know what? I think we did a great job trying to help you discover this field, realize if it's interesting for you, and now you know in which direction you could go if you find it as interesting as we do.
Yes, tell us.
So, if you want to do the exercises on your own, there is a link from Cedric to our GitHub repo. You can clone and do exercises on your own. If you cannot, write me on LinkedIn or by email, and I will create an instance for you. And last 2 words about the upcoming events, because we have a lot of events.
Yes, coming. As usual.
We always have a lot of things for you to do. And I have here, so that's so far best place to subscribe to our events yet is
Okay, let me
Eventbrite
find the link.
Data Stacks. I can copy it. I'm right here.
I will be there soon.
I'm already pasted that.
Oh, too late. Okay.
No worries. Two links are better than one anyway. First one, certification exam workshop coming soon. And certification exam preparation workshop is the great way if you want to get a certified Apache Cassandra developer. Using the resources we are providing right now, you can become a certified developer absolutely for free. You still have to put efforts, a lot of efforts to be honest, but all the training materials, all the video courses, and the certification are free. And you can get your first Apache Cassandra developer certificate or Apache Cassandra administrator certificate, or if you are strong enough, even maybe both, for zero costs only. Put your time into the courses we prepared for you. One session for this exam preparation comes on 2nd of December and one on the 3rd of December. When Data Stacks Monday Learning Introduction to Machine Learning is just over, well, it's not over as long as you want it to be running. Then, Introduction to Cassandra for Developers. If you want to get familiar with the database used by the biggest companies in the world who handle dozens petabytes of data and deliver responses within milliseconds, Cassandra is definitely maybe your choice. Then, Introduction to Cassandra is going to happen, I believe, this Wednesday and this Thursday. Let me find the date. Yep, this Wednesday and this Thursday for different time zones. Content is the same, just pick the date which works better to you, okay? Or you can attend both. We're always happy to see you again. Then, writing Kubernetes native applications. If you was a part of our Docker learning path, or if you're just into the Docker, but you want to improve your skills in this field, then Kubernetes native applications is a great workshop. We have a great guest speaker, and he explains what that's not enough to throw your application to the DevOps guys and they will run it somewhere in the cloud. That doesn't work like that. Efficient application is the shared responsibility. So it both work of operations and developers. And as developers, you have to plan and design and implement your application the way it will be the most efficient when running in the clouds, especially with Kubernetes. Kubernetes native application is the session we discover how it should be designed and how it should work. And finally, putting Apache Cassandra on automatic with Kubernetes is about how do you run Apache Cassandra in Kubernetes. Well, pretty self-explanatory. And one last thing, if you don't mind, that's not a DataStax developers event, but that's an event of QC Bytes meetup group. But I will be speaking there, speaking of designing resilient systems based on the Apache Cassandra example. I would better say it like that. So how exactly Cassandra can be so highly available, disaster tolerant, and work with a huge sets of data still answering so quickly? We discussed the things, how in general do we design resilient systems using Apache Cassandra as an example. So what could we do and what we should avoid designing distributed applications. I will be very happy to see you here on the 10th of November. It's going to be 6:30 p.m. EST.
Yep.
So that's mostly for the United States, guys. Thank you so much. We are always open to your questions at our Discord server. Our workshop for today is over, and thank you so much for being with us. We are really happy to see more and more people to join our questions, join our workshops. And finally, directly under Cedric, you have a subscribe button. And
Oh yeah,
if you are
just
still
there.
with us after almost 2 hours, there is no other choice for you than to press this button. Thank
Brave
you.
yourself.
Yeah.
Yeah.
Thank you so much. You are great and we are happy. And see you next workshop.
Yes, see you soon. Have a good week. Bye.
Have a great week.
I found someone new.